Now, if you see this function here, you have to differentiate by first principle using limits. Now, if you had to do direct differentiation, then it is very easy to do this by the u by v rule, right? But we have to use limits here. So therefore, if I start this, I'll first write fx plus h. Therefore, fx plus h is twice, replace x by x plus h, okay? Once I replace x by x plus h, let's just simplify this a little. 2x plus 2h plus 3 divided by 3x plus 3h plus 2. Okay. Now we write the limit form of differentiation. Therefore, dy dx will be equal to limit h tends to 0, fx plus h minus fx divided by h. Okay. This is equal to, put the values of fx plus h and fx. So you have 2x plus 2h plus 3 divided by 3x plus 3h plus 2 minus fx. Fx is 2x plus 3 divided by 3x plus 2, and this entire thing divided by h. Now we take the LCM in the numerator to get 3x plus 2 into 3x plus 3h plus 2, and you have in the numerator you will get 2x plus 2h plus 3 into 3x plus 2 minus 2x plus 3 into 3x plus 3h plus 2, and this entire thing has to be divided by h, right, which is equal to limit h tends to 0. Now you multiply what is there in the here. So if you multiply, you are going to get 6x square plus 4x plus 6hx plus 4h plus 9x plus 6, okay, minus 2x plus 3 into 3x plus 3h plus 2. If you multiply this, you're going to get 6x square plus 6hx plus 4x plus 9x plus 9h plus 6, and this entire thing divided by h, and this, what happens, this you multiply with the denominator h. This becomes 3x plus 2 into 3x plus 3h plus 2, still an indeterminate form, because we have, if you put h is equal to 0, it will become an indeterminate form, right? So we open the brackets in the numerator to get 6x square plus 4x plus 6hx plus 4h plus 9x plus 6 minus 6x square minus 6hx minus 4x minus 9x minus 9h minus 6, and this entire thing divided by h into 3x plus 2 into 3x plus 3h plus 2, which is equal to, now here if you see 6x square and 6x square is going to cancel, plus 4x is going to cancel with minus 4x, 6hx is going to cancel with minus 6hx, Okay, and 9x is going to cancel with 9x minus 9x, right? So what are you left with here? Limit h tends to 0. If you see here, you are only left with 4h minus 9h, right? Which will give you minus 6h, 5h. 4 minus 9 is 5, right? And in fact, you only, and okay, 1/6 will also cancel here. This will cancel. Okay, so you are only left with 4h minus 9h. So 4 minus 9h is minus 5h. Divide by h into 3x plus 2 into 3x plus 3h plus 2. Okay, now if you see here, this h and this h will cancel. So in the denominator, the h is cancelling. That means you're only left with limit h tends to 0 minus 5 divided by 3x plus 2 into 3x plus 3h plus 2. Now if I put h is equal to 0, will I get a determinate form? Will get,
Yes, sir.
right? So I'll get 3x plus 2 into 3x plus 3 into 0 plus 2. So you are getting here ultimately minus 5 divided by 3x plus 2 whole square. This is what you are getting. And this is the required derivative. Now, if you want to check your answer, you know the u by v rule. You can differentiate this by u by v rule directly and check whether you are getting this or not. Okay, if you are not getting this, that means you have made some mistake either in your direct differentiation or here with limits. Okay, so that is what your answer should be. Moving on to the next question, unless you have any question. Okay, the next question is 1 by x. You need to differentiate 1 by x. So I say let y is equal to fx is equal to 1 by x. Therefore, what is fx plus h? Replace x by x plus h. You get 1 by x plus h. Okay. So therefore, dy dx is, write your limit form of differentiation. Limit h tends to 0. Or you can also write f dash x here. Dy dx is equal to f dash x is equal to limit h tends to 0. Fx plus h minus fx divided by h. Now put the values. Limit h tends to 0. 1 by x plus h minus 1 by x divided by h, right? Which is equal to limit h tends to 0. Take the LCM in the numerator. X into x plus h. So you get x minus x plus h. And the denominator, this remains. And now you have limit h tends to 0. X minus h, right? And this you can multiply here with h. You get h x into x plus h. So this two cancel. So you're left with limit h tends to 0 minus h by hx into x plus h. Now again in this step, this h and this h are going to cancel. Now the denominator, the h is cancelling. That means now we'll get a determinate form, right? If you put h is equal to 0,
Yes, sir.
this is minus. And now we can put, comfortably we can put h is equal to 0 to get, which is minus 1 by x square. And you already know that the derivative of 1 by x is minus 1 by x. I told you to memorize the result, right? So that is how you can check your answer. Let's move to the next question.
Yes, sir.
One part 6. Function given here is 1 by root x plus e, right? Okay. Now, if you want to differentiate this, first of all, I'll find out x plus fx plus h. Fx plus h is 1 by root, replace x by x plus h, you get 1 by root x plus h plus a, right? So therefore, dy dx is f dash x, which is equal to the limit definition of derivative by h, right? Put the values 1 by root x plus h plus a minus 1 by root x plus a whole divided by h. Take the LCM in the numerator. Limit h tends to 0. You take the LCM in the numerator, you're going to get root x plus a into root x plus h plus a, right? Now, here in the numerator, you are going to get root x plus a minus root x plus h plus a. And in the denominator, you have an h, which is equal to limit h tends to 0. You can now write this as root x plus a minus root x plus h plus a divided by h root x plus a, because you can multiply entire thing with h, into root x plus h plus a. Okay. Now, if you see you have an irrational component in the numerator, that is a sum of two irrational components. So we better rationalize the numerator by multiplying by the rationalizing factor. What should be the rationalizing factor? Rationalizing factor should be root x plus a plus root x plus h plus a, right?
Yes, sir.
Divided by h root x plus a into root x plus h plus a into, we have multiplied the numerator and denominator by root x plus a plus root x plus h plus a. Okay. Now the numerator is of the form e square minus b square here. So you're only left with, if you square the radical of x plus a, you simply get x plus a minus, and squaring of the radical of x plus h plus a will only give you x plus h plus a divided by, and you have the entire denominator as it is. Okay. Simplify the numerator by opening the brackets. X plus a minus x minus h minus a divided by h root x plus a root x plus h plus a. The entire denominator will be as it is. Okay. Okay. Now let's see what cancels from the numerator. Plus x and minus x is going to cancel. Plus a and minus a is going to cancel. So you are going to be left with limit h tends to 0 minus h divided by h root x plus a root x plus h plus a and root x plus a plus root x plus h plus a as it is. Now if you see, h and h will cancel from the numerator and the denominator. We're left with limit h tends to 0 minus 1 by root x plus a root x plus h plus a into root x plus a plus root x plus h plus a. Now if I put h is equal to 0, will I get a determinate form?
Yes, sir.
Yes. Let's put h is equal to 0. Okay, which is minus 1 by, and root x plus a into x plus root x plus a will simply give you x plus a. And here what do you have? Root x plus a plus root x plus a will be 2 root x plus a, right? So you get minus 1 divided by twice root x plus a into x plus a, which you can also write as minus 1 by twice x plus a to the power of half into x plus a, which can also be written as minus 1 divided by twice. Now you can add up the powers, x plus a to the power of 3 by 2. And you can also write this as minus 1 by, that is half of x plus a to the power of minus 3 by 2. So out here should be your answer, but this is, you can write it this way, and you can check your differentiation of 1 by root x plus a by your direct differentiation, right? How will you differentiate 1 by root x plus a? X plus a to the power of minus half, isn't it?
Yes, sir.
Which is equal to minus half into x plus a to the power of minus half minus 1 into the coefficient of x, which is 1, right? So you're getting minus half into x plus a to the power of minus 3 by 2. So are we getting here and here? We are getting the same thing, right? Here. So that is how we will be checking. Fine. Let's move to the next question.
Yes, sir.
We are nearing the end of the syllabus now. Okay. After this, we'll just have El Hospital's rule, and then one more chapter is left, uh, which I'll be covering, principle of mathematical induction. Next question is, given function is x plus 1 into 2x minus 3. Now I see this is a product of two polynomials, linear polynomials, isn't it? When it is a product of two linear polynomials, I told you it is always easier to differentiate if you multiply them together first. Okay. So if you are going to multiply these two together, you are going to get 2x square minus x minus 3. Right. Now we are going to find out fx plus h. Fx plus h, you replace x by x plus h. Minus 3. Now, therefore, dy dx, write the limit form f dash x, limit h tends to 0. Put the values. Twice x plus h whole square minus x plus h minus 3 minus fx. Fx here is 2x square minus x minus 3 divided by h. Okay. Limit h tends to 0. Expand by a plus b whole square formula. You are going to get twice x square plus h square plus 2hx. Right? Open the brackets here. You get minus x minus h minus 3. And open the brackets here also. You get minus 2x square plus x plus 3. and this entire thing divided by h. Now you multiply throughout by 2. 2x square plus 2h square plus 4hx minus x minus h minus 3 minus 2x square plus x plus 3. Entire thing divided by h. Now we are going to see here what cancels. So first of all, if you see 2x square and 2x square are going to cancel, right? What else is going to cancel? Plus x and minus x is going to cancel, right? So what are you going to be left with? You're going to be left with 2h square here, right? And you're going to be left with the plus 4hx here, right? And plus 3 and minus 3 is also cancelling here, right? And you're going to be left with only an h here, right? Okay.
Yes, sir.
So if you see, this becomes, you can take h common in the numerator. So this becomes 2h plus 4x minus 1 divided by h, right? Now see, h and h is going to cancel. So now if we put h is equal to 0 in the remaining expression, are we going to get a determinate form? Yes.
Yes, sir.
2 into 0 plus 4x minus 1, which is equal to simply 4x minus 1, which is your answer. And you can check here from your differentiation. You know how to differentiate polynomials, right? You can see it directly. If you're good in differentiation, just by seeing, you can say derivative of this is 4x minus 1. Okay. Last problem. Last problem from first principles. 1, 8. The given function is x square plus 1 by x. Now we are going to simplify again this by dividing the entire the numerator by the denominator. So you get x square by x plus 1 by x, right? So you're only going to get x plus 1 by x, right? This is the given function. So therefore, what should be x plus h? If x plus h, replace x by x plus h, right? This is fx plus h. So therefore, differentiation of this dy dx in limit form would be put the values x plus h plus 1 by x plus h. This is fx plus h. Minus fx is x plus 1 by x divided by h. So you have limit h tends to 0. If you open the brackets, x plus h plus 1 by x plus h minus x minus 1 by x. Entire thing divided by h. Now if you see in the numerator, plus x and minus x is going to cancel. Plus x minus x, right? So we are only going to be left with h plus 1 by x plus h minus 1 by x, entire thing divided by h. Right? Now we take the LCM in the numerator. So you have limit h tends to 0. You take the LCM, you get x into x plus h. So you will get here h x into x plus h plus plus a x, right? Minus, and you have x plus h, right?
Yes, sir.
you're going to get limit h tends to 0, and you can multiply this with this, and you can write this as hx square plus h square x plus x minus h divided by hx into x plus h. Okay, now let's see what all cancel. Plus x and minus x is going to cancel, and nothing else is cancelling. So we are only left with hx square plus h square x minus h divided by hx into x plus h, right? Which is equal to limit h tends to 0. You can take h common to get x square plus h minus 1 divided by hx into x plus h. Now if you see here, h and h will cancel. Now comfortably, if you see, you can put h is equal to 0 to get a determinate form, right?
Yes, sir.
Into x plus 0. Ultimately, you are getting here x square minus 1 by x square, which when divided will give you, which is equal to 1 minus 1 by x square. And that should be your answer. And this differentiation I have also done, right? X plus 1 by x, I have shown you how to differentiate earlier also. So you can check your answer with direct differentiation. Okay. So that is an end to the differentiation from first principles.